There is another arrangement of triangles that comes about very frequently and often enough that it deserves sort of special consideration. So I'm going to draw a picture here, a figure. Let us suppose that these two segments are given to be parallel. I'm going to call this point, again, I'm just picking letters out of the blue sky here. I'm going to call this W, this is B, I'm going to call this S, and let's suppose this is J. Again, I'm just picking letters out of the blue sky, so it doesn't matter what we call these. And let us suppose we're given that WS, the segment WS, and the segment SJ are parallel. So we're given those segments are parallel. And let us suppose we join W with S and J with B. This kind of figure arises in several different kinds of problems you tend to encounter. And so I wanted to make sure and emphasize this with one special video to talk about them. Now, since we're given these segments, since we're given these lines WB and SJ, since we're given those are parallel, let's introduce another piece of notation. Because these two segments cross, we need to label that point as something. Let's call it point R. So R is the intersection points of those two. And now we have two triangles. And what I think it should be clear to see, I want to make sure we can see this. These two triangles are similar. The angles of the triangles are equal. And once we know which angle is equal to what angle, then we should be able to write out the similarity in the correct sequence so that we know what specific sides are in proportion to what. Now, it might look like, what I'm going to write here in the red, this is the red. This is not correct. This is wrong. It is not correct to say triangle BWR is similar to SJR. I claim this is not correct. You may not simply write down the triangles in any order you like and simply assume those are going to be similar. It turns out this is not the correct sequencing. These are not in the correct order. And to see that, recall these two lines are parallel. That was given. Well, look, we now have two parallel lines crossed by transversal WS. Two parallel lines crossed by this transversal. If I were to remove that from the picture, it would look like this, right? So these lines are parallel, crossed by transversal. These two angles, angle at S and angle at W, those angles are alternate interior angles, and we know alternate interior angles are equal. So point W corresponds to point S. And then we also know that we have two parallel lines. They're also crossed by this transversal. So now we have these two given parallel lines, but they're also crossed by this transversal. And this is J, and this is B, and this angle here and here, those angles are alternate interior angles. And we know, since they're given to be parallel, that those angles are equal. Alternate interior angles are equal if and only if the lines are parallel. And so in triangle BWR, the last piece we have is this angle. Well, notice these two angles, they're vertical angles. We knew going in, it doesn't matter what's happening with the lines themselves. Whether these are parallel or not doesn't affect these two. These two are vertical angles. We know those are equal. And so what we have is triangle BWR. B corresponds to angle J, and W corresponds to angle S, and R corresponds to itself. So we have those triangles are similar. And now we can form all sorts of proportions because we know that BW, segment BW corresponds to segment JS. And WR corresponds to SR, and so on around the triangle. So now, suppose we have new given. The point is this: if these lines are given to be parallel, or if you are able to deduce their parallel using some other mechanism, if these two lines are known to be parallel, then the triangles formed by this sort of a structure, those triangles are similar, but you do need to be careful about making sure you have them listed in the correct sequence. All right? So, now suppose we have some more information given. Suppose we're given that BW is given to be 20. Suppose we're given that WR is given to be 14. And suppose we're given that JS is given to be 4. So we're given BW is 20, WR is 14, JS is 4. And what we're asked to do then is find the measure of SR. Given these three pieces of information, find SR. Well, we know the triangles are similar, therefore we know the sides are in proportion. So let's label the picture now. BW is known to be 20, and WR is known to be 14, and JS is known to be 4, and we're asked to find SR. SR, let's just call that X. And so what this amounts to then is we need to set up a similarity, a proportion based upon the similar triangles. But we need to make sure we have things in the correct order. We know that first two letters, BW, right? See, BW is the first two letters. BW corresponds to the first two letters here, JS. BW is to JS. BW is to JS. So we know BW is to JS. Now, how did I know to pick those? Because those values are given. You set up a similarity or a proportion, set up a proportion based upon the values that are given and what it is you want to find. We're also given WR. WR is the second two here. WR in this triangle corresponds to what in that triangle? Do you see it? WR in this triangle corresponds to SR in that triangle. So BW is to JS as WR is to SR. BW is to JS as WR is to SR. And now what's left is fill in the numbers and back solve them, we're out. So it's making sure we understand if the lines are given to be parallel, then we do have similar triangles. Make sure you list the values in the correct sequence. Then use the given information, set up a proportion. Now it's just substitute and simplify. This is, from the rest of this is basic 2 semesters ago algebra or something. So we know BW 20 is to JS. JS is given to be 4, is equal to WR, which is 14 over, don't know yet. Cross multiply, set them equal, solve. Cross multiply, set them equal, solve. So when we cross multiply 20x is equal to 4 times 14. I believe, don't make me square to it, but I believe that's 56. And so x is given to be 56 over 20. As far as I am concerned, you do not need to simplify this. If you want to match your answer to what the textbook says, you will need to simplify your result. As far as I'm concerned, if you left your answer at 56/20, that's fine. But you should know, I have no problem expecting you to know that if you want to simplify that, you should know how that works. What could we do? We could divide by 4, is that right? So this is one way to write this is 14/5, is that right? 14/5 is one way to write that. If you feel like you want to do it this way, or you could write this x is equal to, you could actually do the division. What is that, 2.8? So I don't care which of these final results you pick, but pick one of them. They're all the same thing. Now here's the thing. Let's suppose this is a multiple choice question. If this is a multiple choice question, you might have 56/20 and I might have 14/5. I would expect you to know those are the same thing. You might have 2.8. I might have 14.5. I would expect you to know those are the same thing. So that's on you. You should know basic algebra. You should know basic arithmetic by now. And if your answer is 14.5 and my answer is 2.8, I expect you to know that those are the same thing. And if this is, for example, if this is a multiple choice question, if you get 14/5 and you don't know that those are equal, well, that's on you. You should know that those are the same thing. All right, so the point is, if these are given to be parallel, set up the triangles in the correct sequencing, set up the proportion, and we can back solve and find. And this is whichever one you want to pick. I'm going to pick 14/5, and that's the value for SR.